We are now going to take a look at the second half of Chapter 6, and this was all the trig graphing. The first graph that we learned was the sine function. That one started at the origin and went up, down, down, up. Okay. It could go the other way too. We always did some positive and some negative, and there's those 4 sections because of the 4 quadrants. Let's go take a look at cosine. Cosine always started at a maximum point, at a high, and went down, down, and then it came up, up. Okay, so it went like this. Tangent, okay, you have to know how these things start, always reminded me of x cubed. So it has a point on the origin, goes up, 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 and away like this. Okay, it's got some asymptotes, and then it is periodic, so it continues up, 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 and away. And it goes point, asymptote, point, asymptote, and it continues that pattern. Cotangent, rather, when he starts, it's with an asymptote, and then a point, and then an asymptote. Okay, I'm going to draw some here to the left, and it also has a little reflection compared to that one. So it's down, down, down to the right, down, down, down to the right. Okay, I'm going to switch pen colors here and go back. I did not do cosecant or secant. What you do is you take all of the 0 points, all the middles, and that's where you put the asymptotes. Up at a high, you put a parabola facing up, and at down here at a minimum, you have a parabola facing down. Okay, 2 parabolas make 1 period. For secant, it's the same story. Put the asymptotes wherever there are zeros, and then you've got parabolas opening up and opening down. Okay, let's just draw a little halvesy one here and a little halvesy one there. Okay. All right, so that's what the graphs looked like. How do they start? It's very important that you know how they start. I'm going to stick with my blue marker here and talk about sine. Sine starts on the origin, or you could say a middle, I guess, because it's not always the origin if it gets shifted up, down, or left, right. How does a cosine graph start? It starts at a high, okay, unless it's been reflected, then it might be at a low, a high, or a slash low. How does a tangent start? Okay, he starts at a point on the y-axis. He starts with a point. And then if I shift it left and right, that point gets shifted left and right. And cotangent, he starts with an asymptote. So when I say start to the left, what are you going to draw? Whatever he has at his starting point. How do we calculate period? Period for sine is 2 pi divided by absolute value of b. Same thing for cosine, 2 pi over absolute value of b. But tangent and cotangent is just pi over absolute value of b. A little shorter, short and sweet. Okay. How many sections do we divide the period into? We divide sine and cosine into 4, but tangent, cotangent only get divided into 2. Okay, so they're shorter and smaller there. Which ones have asymptotes? Okay, sine does not have an asymptote, but cosecant does, and secant does. Tangent, of course, and cotangent all have asymptotes. Okay, which one has domain all reals? Domain all reals? Sine does. Sine never stops, and cosine never stops. And that's about it. All right, let's practice looking at some equations and finding the period, for example. This number out in front, right here, let's just tell you what everything does. This would be reflection. This one over the x-axis, of course. The 5 would be a stretch, a vertical stretch. So when we studied this chapter, I said make sure you do a dotted one and then a taller, stretchier one. The good news is the final is multiple choice, so you're not going to be graphing anything. You're going to have to pick the one that looks stretchier. This number right here, this is the B number. This was the A number. and b is the number that affects the period. For tangent and cotangent, the formula is pi divided by absolute value of b, which would be 3/2. And we're not going to leave it like a triple decker like that. So the period would be 2 pi over 3. Let's go ahead and calculate the section too, just for fun. So if it's tangent and cotangent, I'm going to take the period, which is 2 pi over 3, and I'm going to divide that into 2. Dividing it by 2 is kind of like multiplying by a half, and so it would be pi over 3 for a section. Okay, let's take a look at this next one down here. And I can't help but notice that this one does not look ready. Okay, it does not look ready. I'm going to have to make sure that I get the x alone by factoring out the 7. So it's going to be 7 times the quantity x plus, and then this is where sometimes we had a little trouble. So I could put my best guess, and then I'll just distribute it in. Something with a pi. Something 7 times something makes pi. What I'm doing here is dividing out the 7. So let's try that. 7 times pi over 7. Yep, that's going to work. Okay. So the A number is 15, and that's the amplitude. The B number right there is the period, and that's the one that I'm going to want. And C would be a shift. It would be shifting to the left. And I'm going to put a phase shift of pi over 7 to the left. That's what that was called. Okay, but I was supposed to be calculating the period. So let's take the B number, and for sine, it's 2 pi over 7. Done. Let's go ahead and calculate the section for him too, just for fun. So when it's sine and cosine, it's the period divided by 4, which is 1 over 4. And then 4 can cancel with 2 to make pi over 14. Okay, sometimes knowing the sections and the period is enough to pick the correct graph from the multiple choice list. Okay, how do you state things? Let's not forget how to do this. So how do you state like zeros or asymptotes, things like that? Asymptotes. Okay, so it's x equals, and it was always the first one. The first one. And then it's plus or minus something n. And it's always the distance to the next one. So even if the first one is far, far away, you write the first one, and then the distance left or right to all the other ones. Okay, always, let's make sure we say the first positive one. The first positive one, not the first negative one. Make sure to get that equation in ready form. Okay, and what does that mean? It means get the x alone. Kind of like number 2 was right there. Okay, all right, let's do some examples. Graph at least 2 periods of the equation. So first of all, is it ready? And the answer is yes, it's definitely ready. I'm going to go ahead and maybe write his reciprocal one. To graph a secant, we really have to know how to graph a cosine problem. So let's just think about cosine right here. Okay, so there's some things you have to know. What is the amplitude? And that would be a 3. You don't say -3. Negative means reflection. How about the period? The period is 2 pi over b. b is a 1, so it's just 2 pi. And then section. Section. So if you take 2 pi and divide it by 4, that's going to be pi over 2. So this is kind of your basic setup. We've got 1 over 2, 2 over 2, 3 over 2, 4 over 2. And then I'll go ahead and put 4 of them on the left. And this is how we always did them in class. So I'm teaching it the same way, so hopefully some of the bells start going off and you remember how you did it. On the final, sometimes just knowing the information will be enough to select the graph. Or if I give you a graph, this is the kind of things I want you to be looking at closely. All right, so the second thing is amplitude is 3. There's no shifting up and down. So we're going to go as high as 30 and as low as negative 3. Okay. How about shifting left and right? There's a phase shift to the left, pi over 2. So I'm going to go here. This is my starting point. For a cosine graph, that's negative. Do we start high, middle, or low? For a cosine, it's either high or low, and this one's going to be a low. Now don't forget this has to be dotted. So cosine's going to go up, up, down, down, up, up, down, down, okay? And then we're going to put the asymptotes on. Wherever it touches a middle, we're going to go ahead and put some asymptotes on the graph because the actual secant graph are the parabolas. Okay, so this example had a lot of everything in it. Okay, this would be way too long to do on a final, but I might give you a graph and then ask you about some things. So if it's got a maximum point right here, the parabola should be facing up, and this was where we had solid graph. This is the actual secant graph. This one was not shifted up or down, so this one technically doesn't have any zeros. If it said where are the zeros, there would be none. He definitely has some asymptotes. Okay, I could ask you things like domain and range. From negative infinity, the graph goes all the way up to negative 3 and stops. That's a touching point. And then union from 3 to infinity. Okay, so there's lots of things I could ask you if I just draw a graph. And the last one here. Let's graph a cotangent. Okay, step 1, does this look ready? The answer is no, it's not ready. So let's go ahead and get that 2 factored out. Y equals cotangent of x plus dividing by 2. Well, dividing by 2 going to the bottom. I think it's pi over 4. Does that work out? 2 divided by 4. Yes, a half. Okay. What are the questions that we should ask? How about the period? Period for cotangent, remember, is that short one, and it's pi over b, which is pi over 2. A section for him is going to be, divide that into pi over 4. So let's go ahead and label the x-axis. 1 over 4, 2 over 4. Remember how short and sweet it was? I'm just going to do 2 on that side, and I'll just do 2 on this side. You could do more if you want, but this would be enough to kind of, get the ball rolling and at least see what the graph looks like. I've got the period. Oh, let's talk about the shifting now. We have to go pi over 4 to the left, and I really have to remember how a cotangent graph starts. Does he start with a point or an asymptote? The answer is asymptote. So if that is asymptote, that must be point, asymptote, point, asymptote, point, and that's how that works. How does a cotangent graph look? It doesn't look like tangent, not like x when it goes this way. And is there any reflecting? No. So I'm just going to do a regular cotangent graph. Down, down, down to the right. Down, down, down to the right. Down, down, down to the right. Okay, put some arrows down here. All right, that's the graph. And we're going to practice writing some things now. Okay, so how do you write the zeros? To do all the things, it's always the same pattern. X equals, let's find the first one. So you look at the origin of the y-axis and you ask yourself, is there a 0 there? And there is. So I'm going to say 0 plus or minus the distance to the next one. The distance from 0 to pi over 2 is pi over 2n. Left or right, you'll find some more zeros. Okay, how do you state asymptotes? Same process, x equals, let's go find the first one. Okay, the first one, looking at the y-axis, no, and you always go to the right. So the first positive asymptote's right here at pi over 4. Pi over 4 plus or minus the distance from this asymptote to another one is 2 sections later. I really liked the technique where I just slid my fingers and said, well, 2 two sections is a distance of pi over 2, and that's n. And I remember when we studied tangent, cotangent, there was a lot of repeating pattern business going on between the sections here because of every other one. Okay, I hope this is enough to refresh your memory on what graphing was like, and please try the problems and make sure that note card's done. Thank you.